All right, this problem here, 1/2 log base 4 of x plus 2 plus 1/2 log base 4 of x minus 2 is equal to 2/3 log base 4 of 27. Okay, this problem is actually really kind of intense. So let's go and just take care of it one step at a time. We know that we need to use some properties of logarithms here, and all of my bases are 4. So I'm going to go ahead and back all of these 1/2s and the 2/3 in. All right, so what I get is log base 4 of x plus 2 to the 1/2 plus log base 4 of x minus 2 to the 1/2 equals log base 4 of 27 to the 2/3. Well, it seems like the right side is the easier one to handle, so I'm going to take care of that first. Hopefully you guys have enough experience with fractional exponents by now to know that you root it down first, so you get 27, the cube root of 27, which is 3 squared. So what you have is log base 4 of 9. Do we agree with that? Okay, cool. So now, Max, does this make sense to you? No, they are the same thing, right? The 1/2 power and the square root are the same thing. So I'm going to go and just convert these so that they can look a little bit more meaningful. Now, in this problem here on the left side, when we have two logarithms being added together, remember the answer components are being multiplied, right? So when I have the answer components being multiplied, can't I multiply the insides of the radicals? Of course I can. So what I have is a single logarithm of one giant radical of x plus 2 times x minus 2 equals log base 4 of 9. Now, in semester long 3-4, they're learning that these are conjugates, which means that I only need to multiply the first and the last. So this is log base 4 of the square root of x squared minus 4 equals log base 4 of 9. Wow, that was a lot of work just to get here. Now that I have a single logarithm of the same base on both sides, that can go away, and that can go away, and I end up with the square root of x squared minus 4 equals 9. I'm going to square both sides, so I get x squared minus 4 equals 81. X squared is going to equal 85, and x is going to equal plus or minus the square root of 85, which is about 9 point, let's see, halfway between 81 and 100, closer to there, so maybe 9.2-ish, and it's plus or minus. But here's the thing, is that in all logarithm problems where there's an x in the answer component, we have to check our answer. Whoopsie. So go back to the original problem. Actually, I'll rewrite the original problem. 1/2 log base 4 of x minus 2 plus 1/2 log base 4 of x plus 2 equals some crazy answer we don't care about. Any of these not going to work? Max? Yes, you can, but remember, Max, we have to check. So I converted it to a 9.2 so that we could visually see it if one of them isn't going to work. Ty, what do you think? Negative 9.2 is not going to work, so that is gone. So our answer simply is 9.2. Or, Max, in your case, x really is just the square root of 85, not the negative square root of 85. Okay? So that is that was number 98. Next one, 112. Yes. Log base 8 of 15. For this one here, you want to use, remember, the change of base form. Now, the change of base form is something that we touched up on, but we didn't really get quizzed on it. If I want to take a non-base 10 logarithm of a number, there are two different ways I can go about it. And you're going to need a calculator for this. You can either take the common log of the answer and divide it by the common log of the exponent, or you can do the natural log, which I prefer, over the natural log of the base. But it's always the log or natural log of the answer over the log or natural log of the base. And that is how you do, what do you call it? That thing. Change of base formula. Now, I will leave it to you guys to pump this into your calculator and figure out what that is. But having said that, if I was to ask you guys for, say, number 115, which is log base 6 of 47, can anyone just kind of change bases on that and, and tell us what that looks like when the base has been changed? Ty, what do you think? Sounds good. And then pump that into your calculator and you're all set. All right, let's move on. Okay, so do we need to do 114? Another change of base problem? I think that's good enough. Let's see here. 179. Ooh, another page. Oh, you mean 178 twice? So it's 0.456, 456, 456, 456. Okay, so everyone. Okay, so we can say that a sub 1 is equal to 0.456. A sub 2 is equal to 0.000456. And then a sub 3, which we don't really need, but that's really 0.00000456. Who can raise their hand and tell us what is R? Chief, you got a calculator. Can you take 0.000456 divided by 0.456? (0.001). Yeah? Okay, so we have a sub 1 here. We have R. This is an infinite sum, so we say that S is equal to 0.456 all over 1 minus 0.001. So 0.456 all over 0. I believe this is 999. So then I'm going to multiply each top and bottom by 1, 2, 3, so that's 1,000. So I should get 456 over 999. I believe they both divide into 3. 9, plus, yeah, 15. So what's 456 divided by 3, Chief? (152). Let's see here. 6, 8. Yep, this is it. 152 divided by 333. Very cool, very cool. That is how you write an infinitely repeating decimal into a fraction. Number 44. Pause this for a second. Hey, Taylor, can you do me a favor? All right, so with this problem here, we can't factor anything. Well, we can, but it's just going to be a waste of time. Instead, just start canceling stuff right off the bat. One thing I want you to know is that we've got a negative times a negative, so the answer's got to be what? Positive. So this is going to go away, that's going to go away, I get a 2. 3, 9, 3. X squared and gone. So I should end up with 2x squared over 3. Done and done. Yep, that's how you do it. That's actually a little shout out to Mr. Kurth right there. Inside joke between me and him. All right, 54. Now we're talking. 54, I like this problem. 2 over. Okay, guys, I'm going to do a maneuver for you guys, and hopefully you guys remember. I want you guys to raise your hands if you remember this maneuver. I'm going to go 3 over negative 3x squared minus 3. Please raise your hands if you remember a maneuver that looked like that. Great. So this is minus, and then that's 2x squared plus 5x plus 4. So now that I've got a negative and a negative, it becomes positive, and this thing can now go away. And now I'm going to just, yeah, Chief. Oh, is it 4? Sorry. Thank you, Chief. What am I doing? Okay, so it should be 4, and that thing should have been a 4. Okay, so now from here, I just have to factor some stuff out. So this is going to be 2 over x, not x squared, so x looks like plus 4 times x plus 1, yeah? Plus, I'm going to factor this quickly. This is going to be 3 times x minus 1 times x plus 1. Hopefully you guys are able to follow that math right there. So now my common denominator is going to be, let's see, this common denominator is going to be 3 x plus 1, x minus 1, whoops, and x plus 4. So this thing here needs a 3 times an x minus 1. Kind of a bulky problem. And this one needs an x plus 4. Can we agree with that? Yeah. Okay, so now what I get here is 6 parentheses x minus 1 plus 4 parentheses x plus 4 all over the common denominator, which is 3 times x plus 1, x minus 1, and then x plus 4. Alright, so now I'm going to keep moving with this. This is 6x minus 6 plus 4x plus 16, which equals 10x minus plus 10 over, ooh, this is kind of a cool problem, over 3 times x plus 1 times x minus 1 times x plus 4. I rarely see this happen, but one thing you can do is you can factor out a 10 to get x plus 1 on the inside, and then you get your 3x plus 1, x minus 1, x plus 4. I know it's a bit of a process, but those are going to go away, and you end up with 10 over 3 times x minus 1 times x plus 4. It's kind of a neat problem. Long, but it's doable. Alright, that was 54. 50. Ah, yes. Oh, wow. Can we say 50 for the end? Because I have a feeling you guys are going to be dying when you see this. You're going to be like, oh my gosh. I really hope he doesn't assign that on the midterm. But I might. Okay, everybody listen up. This is a very, very multi-layered Inception logarithm problem, okay? So, we're stuck. When we're stuck, we do what with a logarithm equation? Chris? Change forms, which means that 5 to the 0 equals log base 3 of x. What is 5 to the 0 power? 1. So 1 is equal to log base 3 of x. We're stuck again. So how do we get unstuck again? Change forms again, right? 3 to the first equals x. What is 3 to the first? Done. And done. What number was that? 87? Okay, good. 61. Ah, yes. Yes, we don't have that. That's shout out to Teacher Mariano right there. Okay, this problem here is particularly easy. You can actually cross multiply because you have a single fraction on both sides, so that's going to go there. Get x squared plus x minus 2 equals 2x minus 2. Sorry, 2x squared. Let's go ahead and add, subtract the x squareds from both sides. So that, and then I'm also going to go ahead and just subtract x and add 2. So I get x squared minus x. The 2's are going to cancel, and that equals 0. Now, the biggest mistake that I'm going to see is people thinking, oh yeah, that's easy. That's x minus 1 times x plus 1. It's not. They both have an x in common. So what is the only way that I can factor this thing out? Okay? Take an x out of there. X times x minus 1 equals 0. Therefore, x equals 0, 1. Now, you have to check your answer because in the bottom, if I let x equal 1, what happens to this side of the equation? It becomes 0. It becomes 1 over 0. And what happens when you start dividing by 0? I start calling you Scott. That's bad. All right, so 1 is out. Remember, on the midterm, you have to show me that you considered 1 and then marked it off. So you can't just put x equals 0. You have to show me 1 and then crossed off. Yes? Can't divide by 0, right? Scott? Scott, where are you? Can you divide by 0? No. 70. Yes! Excellent problem. Okay, Max. I'm going to do something. Is this okay with you? Because what? They are the same thing. All right? Okay. 5 to the x is equal to... I can change 125 into a base of 5, right? 5 to the what equals 125? 5 to the third, right? And let's not forget that's all being raised to the 1/2 power. And when I have power raised to a power... Teacher Joseph, what do I do when I have power raised to a power? Multiply them, obviously, right? Like ice cream being in the freezer, obviously. I want to roll today. I don't know why. What does x equal? 3/2. Boom. Max. Okay, remember, Max, when you have exponent being raised to an exponent, you multiply your exponents. So 3 times 1/2 is 3/2. Okay? That was 70. Okay, so 156. All right, hang in there, guys. 156. Okay. 156 really is just kind of a barrel problem. Like, you have to just do it. And it's asking you to sum up the numbers between with the terms 1 and 4. Okay, so you just have to barrel through this one. And when you get a sub 1, or a sub 1 is going to be 10 times 1 minus 3. A sub 2 is going to be 10 times 2 minus 3. A sub 3 is going to be 10 times 3 minus 3. And then a sub 4 is going to be 10 times 4 minus 3. Remember, sigma means summation, which means that you are actually going to... give me that option. You have to add all these terms together. All right? So this is 10 minus 3, which is 7. This is 20 minus 3, which is 17. This is 27, and this is 37. So the problem really is 7 plus 17 plus 27 plus 37. In your calculators, I trust that you can do that. Gabby. Every time you see a sigma, they're asking you to add up all the terms. All right, very cool. We'll be back in a little bit. Just kidding, we're back now. 50. Forgot about that problem. I like 50. It challenges you on a few different levels. Hey, Ms. Cruz. Thank you. It challenges you on a couple of different levels here. It is x to the 4th minus y to the 4th over x to the 3rd plus y to the 3rd over x to the 3rd minus y to the 3rd over x plus y. All right. Well, it's a complex fraction, which means that I hope this makes sense to you. If I do this, is everyone okay with me doing that and replacing this thing and getting rid of it? Yeah? Okay, cool. So now we got to factor this thing. This is a bare factor problem. I mean, the top is going to become x squared minus y squared times x squared plus y squared over x to the 3rd plus y to the 3rd times x plus y over x to the 3rd minus y to the 3rd. Okay, now, we can still factor a bunch of things. This left term here can become x plus y times, x minus y. All over, I'm sorry, I forgot about this thing, x squared plus y squared. All over, remember this, when the two things are being cubed, what kind of problem was this? I don't remember, we're learning about it in semester 3-4 right now. The factor scenario looks kind of like that. x plus y, x squared, x, y. What are the symbols? Negative, positive. And this is x plus y over. Same thing except minus, right? So x squared, x, y squared. It looks like positive, positive. Okay, what's going to get out of here? The x minus y's are going to cancel. The x plus y's are going to cancel. I'll go top to bottom. And so what you end up with is, there's nothing else I can cancel. X plus y times x squared plus y squared over, wow, x squared minus xy plus y squared times x squared plus xy plus y squared. Ugly problem. Very ugly. But I like it. I remember more stuff canceling the last time I did it, though, but I don't know. I think I did it right. All right, people. We'll be back in a flash.